Hey there, welcome back to Coding at Home. Hey there, welcome back to Coding at Home. I'm Matt with the Code Hub. Today we're going to finish off Sensor Arcade. You guys have built some amazing games, and we've used all sorts of sensors with the iPad. We've used the light sensor, the microphone, we've used the touch screen, and we've also used the Sprite Kit collision capabilities, where we can detect whether or not two sprites, which are graphics that we're most familiar with, have collided with one another. Yesterday we played around with Bumper Bash, and we detected collisions of the pinball hitting different bumpers. I'm going to show you a couple hacks that the guys downstairs did last night. When we finished the session, they showed me some of the code they'd written, including some of the hacks they used to beat my high score. Maybe you figured out the same trick. And we're also going to talk about Gem Hunter and maybe implement a light sensor event handler. So remember, this playground is all about handling events, and those events are coming from those different sensors. We deal with that a lot in programming, whether it's on the iPad, whether it's for the web, could be anywhere. So let's hop over to the iPad and get set up, because I can see that my camera is lagging behind. All right. So we should be over here, and actually we're going to quit Xcode, which is not some object. We're going to start playgrounds as usual. Actually, we're going to quit a few of these just to give ourselves a bit of headroom. Should tell you what, we're going to restart this for 1 second. Bear with us. Hey there, welcome back for real this time to Coding at Home. Hey there, I'm Matt with the Code Hub. Welcome back to Coding at Home. Today we're going to work on Sensor Arcade a bit more. We're going to finish it off. We already have sort of finished it off. We've done Bumper Bash and we've done Gem Hunter, which are the last two playground pages with actual games we have to implement. We're going to go through some of the stuff that the guys downstairs implemented last night. They beat my high score. They may have cheated. I'm going to show you some of those ways to cheat. You may have already figured out how to do that yourself. That's part of what we do as programmers, is we figure out the easiest ways around a particular solution. And their goal was to beat my high score, which is not that high anyway. So we're going to take a look at some techniques we can use to beat that high score, some little cheats, and we're going to implement our light sensor as an input for our Gem Hunter game and see how we can do. See if we can beat my high score from yesterday by implementing that. And then we'll talk about where we go next from here, because we're done with our next playground, our next big challenge, and I have a really interesting puzzle for us to work through for the next few days over the next few days anyway. All right, so without any further ado, let's hop over to the iPad. All right, so here we go. We're going to open up Swift Playgrounds as per usual. We're playing around with Sensor Arcade today. All right, so where we left off was Gem Hunter. We implemented some code here. We used the volume. Now this was already implemented for us. We have a handle touch moved. We have our handle collision. We implemented some of this code. Maybe, or maybe we actually didn't touch any of this. So let's go back for a second though and look at Bumper Bash. So here we had a game where if we run our code, we'll see that we had a pinball and our goal was to react to hitting these different elements on the screen. So if I hit play, we're going to start. We're going to hit the green button, and off we go. We're hitting the green bumper, and we're detecting collisions between our pinball and these different colored bumpers, and then the springs on the side of our pinball game. So, okay, so we got 23. That's a new high score. Pretty good for doing not much of anything. Now, what we did to implement this was we used the angle that we're detecting the collision at. So the y and the x value of our angle, we're reversing it so that when it hits, it will go back the exact opposite way. And then we apply a force. We actually get a force from our collision. So we can use that value to see, well, how fast was the pinball traveling when it collided with the other object? And that's how we end our game. Now, this was a good use of a bit of coding, clever alternative coding. I had one student say that, all right, well, if the names contain a ball and if names contains the end game, we're not going to end the game. If you remember, we checked this array here, this names array, for the presence of two names. So in a collision, we have two objects that can collide, sprite A and sprite B. And if you remember, we talked about sprites yesterday being basically just graphics. That's what when we're programming a game, each little distinct object on the screen, we might use a sprite for. So what we do is we check and we say, well, if the names array contains the word ball and it contains the word green bumper, then it's a collision between the ball and the green bumper. Sprite A could be ball or it could be green bumper, and sprite B could be ball or green bumper. We're going to run this code. And we always apply our impulse to our pinball. Same thing with ball and pink bumper. You can see here, the green bumper is a bit more dull, right? It just uses the force. It doesn't multiply it by anything. But when we hit the pink bumper, you can see that it really shoots off that pink bumper because we're multiplying the force times 5 and then also multiplying by the x direction that we calculated up above here. And then we apply an impulse. Now we also saw the method apply force. We're going to see what that does in just a second. But first, I'm going to show you the little hack that one of the guys did. So what we're going to do is we're going to actually delete endgame. So now what we're going to do is we're going to detect when the ball hits that endgame sprite, and we're going to actually apply an impulse to the pinball. So we'll go find pinball here, and we'll do pinball dot apply impulse, and we'll shoot it back in the direction it came from. So we'll do xdir, and we'll give it a bit of force. We'll actually use the collision force property. So collision dot force. And then we'll actually give that a multiplier because maybe that looks like a bit springy, the end game piece. So we'll multiply it by, say we'll multiply it by, what did we do? 5 for the, well, 100 for the spring, 5 for the pink bumper. Let's do 10 for the end game. And we'll do the same for the y direction. So we'll do ydir times collision.force, collision.force, and then we'll do multiplied by 10 as well. So let's run our code now and see what happens. So we'll play, because we've just altered the end game, which doesn't actually come into play when we're practicing. We'll hit the green button down here. Off we go. Okay, we got 6, 9, 12. Okay, good. We're getting a good score. You see, we hit the bottom, but we're still going. So my high score of, what was it, 23 or 24? I've beaten that already. Now, the only problem with this hack is that I won't get credit for my score. So I have a great score right now of 50, but I'm never going to get credit for it because we're never going to end the game because nowhere do we call end game. And now I've rested at the bottom, so I'm actually not even moving. So 56 is as high as I'm going to get. So that was one way to get a new high score. That's kind of cool. Let's change that because that's cheating. Let's delete all this. Oops. We're just going to select all of this and we're going to delete it. We're going to put endgame back in there. So we'll say endgame. Now we could use some of our knowledge of timers, maybe, and say, all right, we'll set a timer and see if when we hit the end game thing, maybe apply an impulse and then set a timer to end the game after 10 more seconds or 15 more seconds. That might not be bad. I mean, it'd be cheating still, but it might not be bad. All right, so that's our end game. I saw another interesting thing because somebody wanted to use apply force. So let's try doing that. So on our spring, let's comment out this one. And remember, commenting out our code lets us see what we had done, because maybe we're not sure. Maybe we want to test this out. We just want to test something out. So I don't want to delete it because I don't want to have to rewrite it all. So I'll just put 2 slashes in front of it. So I'm going to take pinball. So pinball dot, and we're going to use apply force instead of apply impulse. So we'll do the same thing. We'll use the X direction because we want to apply the force opposite of where the spring hits. We'll multiply it by the collision because we'll have that equal and opposite reaction. And maybe that's all we'll do actually. We'll just multiply it by the collision dot force instead of giving it any multiplier. And the same thing with the Y direction. We'll do Y dir times collision dot force. So we'll do collision dot force. Now there's an interesting extra parameter here that we have to specify for force. So it's a duration. So this is in seconds. So this is how long we're going to apply this force. So the opposite of how hard we hit. So imagine we're coming down this soft, it's going to apply that same force going in that direction for however long we specify here. So let's say 10, just to experiment. So let's run our code, and we're going to see what happens when we get inside here, when the names contains a spring and contains ball. So let's run our code. And we'll play. We could have practiced too, because there are springs in the practice mode. Now I'll hit the green button and off we go. Okay, well we ended right away. Not super exciting. And we did hit the spring, but we kind of rolled down it. That's why there wasn't much force applied, I guess. Let's try that again. Actually, let's practice to see if we can drop it on it and test it out. So we're going to drop our ball, if I can actually drop it on a spring. So you'll notice that our ball, when we apply the force, it's not the same, it doesn't get that same big push. But it does tend to roll away from our spring. And in fact, you can still see it. So I hit a spring, and when I drop my ball, it's actually not dropping in the same direction. Let's give this a multiplier. Instead of just using the collision force, we'll actually give it a multiplier to really show off what this force is doing. We'll do multiplied by, let's multiply it by 10, and we'll multiply the X direction by the same thing, by 10. So multiplied by 10. We're changing our parameters here inside the pinball.apply force method. We'll hit run my code. And we'll just practice. So here we go. I'm going to drop it right on the spring. You'll note that my pinball seems to be defying gravity. That's because the force is being applied. So I dropped it in this direction, and it got pushed this way, hit another ball, and got applied an impulse to it, and then but kept persisting. Because for 10 seconds, I was applying a force. Same thing over here. So I managed to hit this one, and then I also hit this one. So I started to apply a force this way. So if I drop a ball on this spring and it doesn't hit anything, any of the other springs, it'll always push it up to this corner for 10 seconds. And if I hit one of these springs, it'll push it up to this corner for 10 seconds. Here, we'll try that out. So because all I hit were these things where they applied a little impulse to it, the force overrode those for the 10 seconds that I was applying that force. That might be another way that we want to try handling our collision. Maybe we want to apply a force. We'd probably want to do it for less. So maybe try it for a second. Let's try playing our game and having our springs apply a force rather than an impulse. Let's hit play. And we'll run our code. Okay, not great. 13. Not too bad. Could be better. So you can see that when we apply the force, it's a little bit different than apply impulse. Impulse, when we apply an impulse, is more like a punch, where someone punches and then pulls their hand back. Applying a force is more like someone's pushing you. So let's delete all of this. And we'll add our code back in. We've got pretty strong springs. Our pink bumper is a 5. Let's try again. Let's hit run my code and try that again. We'll play. And here we go. 2. Okay, pretty dismal. But you can see that those are a couple of the little hacks that we could have done. You could apply a force rather than applying an impulse. You can choose to not end the game if you don't want. Let's see. The last thing I wanted to check just to make sure here. Pinball dot. So we have apply force, apply impulse. Is there anything we're missing here? We can set the velocity. We can fade it. We could have an orbit. Rotate, scale. There's a whole bunch of functions here, methods on our pinball, that we might be able to use to help boost our score. So let's do this just for kicks, because we're talking about cheating a little bit. Let's do this. We're going to make our pinball get bigger and bigger when it hits the spring. So we're going to scale it by 1.5 times for 5 seconds when it hits the spring. Let's run our code. Today's lesson is all about how you can cheat at pinball. Okay, 22. Almost beat our high score. So that's just a few of the things that we can try. Maybe make it an even bigger scale so that it really gets stuck in the middle of those pinballs. Loads of things we could do to keep cheating. Now let's go back over to Gem Hunter. So I just hit the next arrow to go over to Gem Hunter. So what we have so far is we have our sound. So if the sound gets louder, then here, we'll move this over so we can see all of our code. If the sound gets louder than half, we'll apply an impulse of going up. If you're in a quiet room, maybe you want to use the little sort of handy helper tool that we can specify to change the sound. We can handle touch moved. So when we touch on the screen, it'll change the X position of our player and it'll make them dash at a certain speed. And this is the kind of thing we might tweak. Maybe taking the X direction and dividing it by 2, cutting it in half, maybe that's not what we want. Maybe we want him to dash faster. So what we might do is say, actually just make the speed the X direction. And remember, the X direction is going to depend on where we put our finger down on the X axis and the player position. So if the player is over here and I'm over here, when I touch, it's going to be a larger value than if I touch closer to where the player is. So the player will go faster the further away from its position I touch. We have a handle collision. Now, we could do a similar thing and say, actually, do you know what? If I hit the spikes, I don't want to end the game. And so now I could run my code. Now, we might check and see if we can see, is there a score property here? Maybe the score is on the scene. Actually, I have not checked this out. So your guess is as good as mine. All right, so there's none. There's no score that we can kind of easily access. And get back to Swift Playgrounds. We'll delete that and delete that. Let's run our code and try this out. The only thing we did was we turned off end game. We'll play it. Now, down here is our little volume control, just in case we don't want to use our actual volume. So we'll turn the volume up, and then you can see I can make the giraffe move much quicker. And if we talk really loud, there we go, we've moved our giraffe. I'm actually sitting on some spikes, which isn't great. Here we go, jumping up there. And over. And we're on the spikes again. We're having a great time though, because we're able to move our giraffe over without worrying about these spikes. So that's kind of handy. This is a deadly one. There we go. Oh, great. So we got a score of 8 when the timer ran down. So we still didn't, even though we were cheating, didn't manage to beat our high score. Kind of embarrassing. So let's turn off our little cheat when we hit spikes. The last thing we can do here is maybe let's shrink our giraffe down when the light sensor is kind of low. So we're going to create a new function here. We'll hit the func keyword down in the autocomplete bar. We'll call this handle. Move that guy out of the way. Handle, I'll put the caps on because we're going to do a camel case light event. Now you remember when we handled the light event, it took a parameter of a color, right? So we'll add a parameter by tapping on our parentheses at the end of our function definition. And we'll drag over. And now we'll call it light, and it's of type, you might remember this, it's of type color. And so the function body, what we're going to do is we're going to change the scale of our giraffe based on the light. So let's see. So our player, there it is, player dot. Maybe we'll say, actually, we have access to a duck or jump. So let's try doing jump, actually. Maybe we'll use jump to make the player jump. So on the x-axis, when we're using our the light sensor, we won't jump at all. We'll just do 0. So we won't move on the x-axis, but we will go up. Well, we could Well, if we do 10, watch what happens. So we've hard coded a value in here. We're not using any of the data that gets sent into us. If I hit run my code now, nothing's going to happen. Even if I put my finger over the camera, because the light will change. This won't get called though, because I haven't set my light handler on the scene. So now I have to do scene dot, and we're going to go over here and find our, so there's our set on touch moved. Let's start typing it in to see if we can get it. Set on collision, on touch moved. Oh, where is our light sensor? Actually, we need to create a light sensor, don't we? So let's go back to Dashing Donuts, because that's where we did it. We need to create a light sensor. So let's go do that. So we have a tone sensor set here. Let's create our light sensor. And we'll start typing in capital L. There's our type, light sensor. So we'll create an initializer. To initialize a light sensor, we use our parentheses. We pass in a configuration. We're going to use the front camera. So we'll use a dot and then front. Okay, so now we can go down here. And it's not the scene we want to set our light event handler on. We want to set it on our light sensor. So we'll change scene to light sensor. And we'll do set. And the nice thing, I started writing out the function already, or the method already. And it auto-completes for me down there in the auto-complete bar. And then it even says, oh, yep, that has the right signature, because there's our handler. And in parentheses, it has color. That's what we're looking for a parameter. So now if we run our code, we'll see what happens to our giraffe. So now we have the two utility panels down here. We have our sound control and our light control, so we can change it down there. Let's practice. Okay, so you can see that our giraffe is looking a little bit jumpy because we're getting light updates all the time. So, and they're not according to any kind of input we're getting. We're just saying, oh, yep, always jump by 10. So we can see that we're not changing a whole lot. So it's always floating up in the air and kind of vibrating. So let's not do that. So what we're going to do is we're going to have that Y value be equal to something with our light. So let's say let brightness equal to, and then if we ask the light for its brightness property, so we're going to say dot brightness. Now we saw before that it was a certain value, I think between 0 and 1.0. So let's do that. Let's create a label so we can actually see it. So we're going to do and we're going to call this brightness label, because that's what we want to show. And we're going to create a label. And we'll say, to start with, we'll start with 0. Dot 0. And we'll give it a color. We'll pick a color of, how about we pick that? Perfect. All right. Now there's a problem with this, as we can see from our red dot. So it's saying, hey, this is a double that you gave me here, this 0.0, and it's not a string. So to make this a string, what do? Well, we'd put it inside quotes. I'm going to tap on the space bar and move my cursor around. So if you tap and hold on the space bar, the keyboard kind of grays out, and then you can move the cursor around. Super handy little tip. So now that we have our brightness label, we want to add this to the scene. So we'll do scene dot place. So let's place it up in this corner up here. So we're going to place our label, our brightness label, at point. So we need to create a point. So there's our point type. There's our open parentheses, X and Y values. So we're going to do minus, say 300. And the Y value will be 300. And now that we have our brightness label, we want to update its value. So we will go down to our light handler. And the first thing we're going to do here is we have our brightness label defined outside of all these functions, so we can access it in here. Here it is. So we can do brightness label dot text equals, and then the way we can't just do something like this. We can't just do brightness, because we're going to have the same error that we had before. If we try running our code, we have this error here. Cannot assign value of type double to type string. So we could do this. Well, this isn't going to work. Here, we could just do this. We're going to bring up the keyboard. We're going to enclose this thing in quotes. But this isn't going to be very useful, because what's going to happen now is we're just going to see brightness displayed in our label. And there it is, just says brightness. That's not what we want. So the way to get a variable, especially a number variable, into a string, this is one way. You can enclose it in parentheses, like so. Oops. Like so. And then before the first parentheses, to let Swift know that it should turn that number variable into a string, you use the backslash. So this one that faces, the one over the N, that faces that way. And you can see immediately that changes from red, which told me it was a string, to white, which tells me it's a bit of code it's going to try to interpret. So let's run our code and see now. Okay, all right. So there we see our label's going a little bit crazy as it updates, and it's staying around 0.6. So that's the value we're working with. We still have our guy jumping like crazy. So we could try just saying, well, make the jump be the brightness. So the lighter it is, the higher he's going to jump. Now, not very high. Let's try running our code and see what happens. And if we lower it way down to 0, see, he's still kind of shaking because he's getting updated a lot. So maybe this isn't the best idea to use our handle light event to change the scale or to have our player jump. Or maybe it is. Maybe this is a way to get us across quickly. We can go back over this way. If we talk a little bit louder, we'll get him up in that corner. And it's kind of hard to get him to move because he's so twitchy. But maybe this is how we would... Let's try it out. Let's see if this is any better. I have a feeling it's not going to be a great solution. And if we keep talking, because we'll need to talk or use that thing. There we go. And if we talk again, we get him up in the corner. The problem is when we go down, and we can't do quite as much talking. We've only got 30 seconds left. But at least I know I'm not going to hit the spikes on the ground. we're moving fast-ish. There we go. We've got one more. Got a score of 9. Do you think we'll beat our high score? No, I don't think we will. 8. All right. Well, that was a good attempt. So maybe the light event isn't the right place because we can see that this gets called a lot. So we want to do something that maybe isn't quite so jerky. It doesn't do quite as much. Or we check to make sure the brightness is above a certain level, and then we'll have it jump. So maybe what we do is say, use a condition. So we'd use an if condition to say, all right, well, if the brightness is, well, let's not do greater then, because it's pretty bright in here, is less than 0. Let's say 4. That's when we'll do this, to run this code. So we'll expand that. We'll drag down. Now let's try it. So we'll have that weird kind of float effect when the brightness goes way down. Okay, so let's play and let's try it out. 3, 2, 1. Here we go. I don't even have to do any talking. And if we talk really loud, then we go shooting up. And we go shooting up again. And we go over this way and we talk again. We talk again. Oh, lower our brightness. Oh, cool. This might be it. This might be the one, guys. It gets us at least over our old score. Oh, so close. All right, well, 9 is not too bad. So those are a few things that we can try with our Gem Hunter. We're going to go on to our next page because this is going to tell us all about Sensor Create. Now this is where we can build a game and use those collisions, just like we did with Build an App Aquarium. We are going to have a small pivot tomorrow, and we're going to go check out another playground. But then I think that we'll come back to Sensor Create and we'll work on building a new game, or maybe taking the old game that you built in Build an App Aquarium and re-implement it with our Sensor Create playground. So come back tomorrow. We're going to be working on an amazing playground that tells a story. I think it's one of the best playgrounds that is available on Swift Playgrounds. And I think you'll really like it. All right. Please like and subscribe, and we'll see you tomorrow.